I'm going to talk about using Lightning kind of in a production environment. And the things I'll cover are um, how to run your node that's backing your service, and then also how we're thinking about backups in LND. So it's a pretty common question. Like if I talk to people who are getting ready to like go live with their Lightning deployment, like offering a new service, a lot of people are like, oh, what do I need to really be thinking about as far as how should my production environment be set up, that kind of thing. And with Lightning, there's a lot of different things you need to be thinking about because it's a complicated stack. So you need to be thinking like, what happens if your disk dies? What happens if you don't have network? A hacker gets access to your computer, you get DOS'd. Maybe the implementation itself has bugs. Maybe your application has bugs. Maybe you do have your disk, but it has old state. You leak pre-images. So there's all these different components that you have to be thinking about, like, what's my disaster plan? So we already kind of talked about this, but one thing that LND is favoring at the moment is this idea called data loss protection protocol. And the idea is, let's say I have old state. That's at the moment, that's one of the most dangerous things that your Lightning wallet can have is an older version of the channel where you could potentially get this breach scenario. So data loss protection protocol is something that is initiated when you connect to a peer and you say, basically, here's my current version of the commitment transaction. Here's my current state, and is this a reasonable state? And then and there's another component to data loss protection protocol which involves the commitment transaction secret. So this kind of like gives a dual purpose to data loss protection protocol. So does anybody know what happens if there's a channel that's force closed? You know what happens if the other side force closes their channel by broadcasting the commitment transaction? Do you guys know which output is which? So like who gets it, the other side? The other side broadcasts their old commitment, the current commitment transaction to the blockchain, and who's the remote case? So yeah, you're the remote case, and the constraint on the remote case is just a key. So it pays to a normal public key, and the key is derived from your. So it's a normal not the normal, yeah. So not to give away the game, but the key is why can't I use my mnemonic seed, my derivation path to get those funds? Does anybody know why? Why? So why couldn't I use my HD seed? So this 2 remote is not constrained by a CSV. It's not constrained by hardly anything, just this one key. So but my seed doesn't cover it. I can't use my seed to sweep those funds. And why is that?
Your seed doesn't know the funding transaction, which the commitment transaction refers to.
Yeah, but why couldn't it just scan? Why couldn't it scan the blockchain?
Well, it would have to also know the network graph of all the channels, because the channel is a multi-sig.
Well, this output exists on the blockchain, right? It's something that is as soon as it confirms, it's part of the blockchain and it's spending to a normal pay to public key address.
Oh wait, because you can just arbitrarily set this remote key address to something that you control. Yeah, I don't know why.
You can revoke things which aren't revoked.
Revoke things which aren't revoked.
Sorry, so you can derive the key forwards. So you have a replication key for the next state.
Okay. No, not. I mean, but I put the clue in the slide, which is that there's every commitment state there's a secret, right? There's a nonce, and this nonce is updated every time you update the commitment transaction, and it's kind of designed to randomize the transaction. But it has the effect that because this nonce is not part of your seed, even though the public key is derived from your seed, the normal remote public key is derived from your seed, you don't know that key. You need that nonce. So that's a dual purpose of the data loss protection protocol. Is as soon as you talk to this peer, the peer does know the secret, and so they can tell you that secret, and they can say, "Oh, here's how you recover your funds." Okay, so L&D has this concept called static channel backups, and we've built it based on this data loss protection protocol. And what we do is we give you this kind of blob of data, and we say, this is your backup. And the nice thing about this from a user experience point of view is you only have to do it one time. You only have to make this backup one time at the start of your channel and on a per channel basis. And if the data loss protection protocol holds true, you'll be able to use this one file plus your mnemonic to reclaim all your funds. And the way it will do that is it will say, it will encode the peer that you have that's part of this channel, and it will encode the channel ID and some other information. And let's say you lose all your data, you lose your disk, or maybe you lose your disk. So you still have your mnemonic, you still have your channel backup. So what you do is you go and get your channel backup, you decrypt it using your mnemonic. You say, oh, there's all this list of peers that I used to have channels with, and here's all the channels that I had with them. You go and contact all of these peers, and you basically say, I'm at state 0. I have lost, total track of like what state I'm supposed to be on. And what the peer will do in response is, it will, as long as it's following the data loss protection protocol, is it will say, here's a nonce for you. Here's a nonce that corresponds, that will allow you to claim your funds from the to remote state, and it will broadcast its commitment transaction to the blockchain because it knows it can't carry this channel anymore. Okay, so obviously SCB has a lot of drawbacks to it. One thing I didn't mention that I should have mentioned is that HTLCs that are in flight, well, they're not covered by this. Like, you generated a pre-image maybe, and you thought that you got some money coming into you. So that part, is dynamic and is not covered by that static channel backup that you made one time and put in a safe place. So another practical thing that you can do if you're deploying Lightning right now and you're putting in, lots of money into it, is that you can use disk replication. So the way that LND is written, and I assume all the other implementations, first, whenever you're doing something, first you go to disk. And then you get like an ACK from the disk that says, oh yeah, I've written that data to the disk. And then once you're confident that that state is on the disk, then you go to the peer and say, okay, here's the updated state. So I would definitely recommend that if you're putting a good amount of money on, that you use a disk that is maybe a replicated disk. Amazon has like EBS, you do RAID. So at the very least, if one of these physical disks catches on fire or something, there is another one who has the state. And this is kind of like dealt with at an abstraction layer that is somewhere else. And that's something you can do today with not without too much effort. So in the future, we're coming up with another solution called dynamic channel backups, which will be a complement to static channel backups. But I would say that it's a complement only because we have a fundamental problem with old states in Lightning as it is today, which is they're so dangerous. So if you ever do think that maybe you are in a state where you have an old version of the channel, it might just be that your best course of action is to still use the static channel backup and still initiate data loss protection protocol, rather than risk even the slightest risk that you're using an old state of the channel. So it's it depends on the wallet, it depends on the circumstance, your peers, but we always envision the static channel backup as like the firewall against you shooting yourself in the foot. Okay, so another thing another drawback of static channel backups is that whenever you contact a peer and you tell them, hey, I have this I don't know what the state is, you're really giving them a good advertisement that it's time for them to attack you because you don't know anything. So that's where we have the watchtowers. So if you have a watchtower that's outsourcing the breach monitoring for you, then you kind of like can safely use this static channel backup because if they try anything, the watchtower will get them. Okay, so these 4 components, though, are what we're thinking of as the overall package of preventing the worst case scenario. Okay, so I'll just kind of like go over how our watchtower system works, just again, and talk a little bit about like some of the trade-offs. So you already heard that the justice transactions, the way watchtowers work, is actually super simple, right? You pre-compute these transactions, like you predict how they're going to look in the future, and then you use half of the transaction ID as an encryption key, and you then encrypt that transaction, and then you send it off to like basically a server that is looking for something that matches that transaction ID. And it's always looking, and when it finds it, it uses that encryption key, decrypts that transaction, broadcasts the transaction, justice is served. So there's a lot of complexity, though, just in the edge cases. So one thing to think about is like, what if I computed the wrong fee for that justice transaction? Maybe I thought that transaction would confirm fee A, but now the fees are totally different from when I set that up with a watchtower. So that transaction is not confirming in time. So we can do stuff with like increasing fees, updating fees. We can set up time locks, but it's kind of something we have to think about like in the actual details of implementing it. The other problem is with HTLCs. So the more HTLCs that you add on to your commitment transactions that you're backing up to your watchtowers, the more possible signatures we're getting, and we get like a blow up on the size of each update. And also, you want to be careful like who your watchtower is. You don't want to choose watchtowers. So in the current version of LND, where we support watchtowers, we don't support watchtowers that are external, that are not you, or that you don't have some level of trust with. So this is basically a redundancy tool. Like I can set up another server for myself that's watching my other server to just make sure that nothing is going wrong. But let's say that we intend to make this into something that people can offer as a service, and that you could go to a few different people and say, please be my watchtower. But in that case, you should be careful not to choose your peer as your watchtower, because then they're watching themselves. That's not a good scenario. But overall, I think there's been a lot of attention paid to watchtowers that is outside of the influence that they've had actually on practical usage. So people have talked so much about watchtowers, but we don't even have watchtowers still. And Lightning has gone on, into it's been used by thousands and thousands of people. I've run thousands and thousands of channels, and how many breaches have I had? I've had one breach, and it was probably caused by this out-of-date state situation. So I wouldn't say that watchtowers are like the #1 issue that's facing adoption or even facing user security of their funds. And part of that is based on the penalty. Because we have such a severe penalty, it makes it very unattractive to try to breach somebody. And that's something that's not solved by L2. Yeah. Okay. Yeah. Yeah. Okay, so I want to talk about one thing that's important in production. A lot of those hard problems in Lightning are kind of pushed off to the reader. So like, what fee should you set? That's your decision. What kind of channel should you create? That's another thing that is your decision. Who should I peer with? And then what should be the constraints around my peering with people? So we kind of leave that to be like a market decision. I want to talk about one problem that I saw in my own node, which is based on this idea that people had that they're going to connect directly to all the merchants that they use. So when people like started using their Lightning apps, they were like, well, I'm just going to connect directly to yalls.org. And then, every time that I view an article on yalls.org, I'm going to update my one channel with them. And if I buy stuff from other people, I'm going to use different channels that I have with those people. So what ends up happening is you can see in this top chart, what happens is let's say that they make a payment to me, or maybe they're routing through me, and it's a small amount. I'm getting these tiny UTXOs. So I don't manage my channels in the same way. I try to limit the amount of channels that I create outwards because I want to get aggregation, right? I want to aggregate my transactions. So I want to have maximal amount of transactions per chain transaction. But because they're not thinking this way, they're creating all of these like tiny UTXOs for me. And maybe they were just playing with Lightning or something. So at some point they're like, oh, I'm going to switch wallets now. And what they leave me with is they close their channel and they leave me with like a 5-cent UTXO or like a 35-cent UTXO. And then when I go and I want to claim all my money, even though maybe I forwarded for them, $1 collectively, I have maybe 100 1-penny UTXOs. So that's not a good situation for me to be in. I want to have some good UTXOs where with the chain costs, I'm still coming out ahead. So in the short term, the way that I've dealt with this is by increasing my minimum channel size, so that to kind of get the point across to people that what is my current minimum channel size? So it's not a conclusive solution, but it's currently set at 4 million, and the idea was that's like the maximum size payment that you could make. So I want people to really have this point of view where it's like I'm trying to funnel lots and lots of off-chain transactions into a small set of on-chain transactions. So that's kind of like the tool we have at the moment is this minimum channel size. In the future, LND will support a more nuanced version of how to accept channels, which will be interactive. So it'll basically be you can kind of either totally take it on yourself, and like there'll be like an API that calls out a hook to you, but if that's too difficult, we'll also have like channel policies which kind of describe like what type of a peer you want to allow to create a channel with you. And we also need to work on like trying to figure out like who is a good peer, like from the what are sensible policies, that kind of thing. So I'm going too slowly. So the second thing I'm going to talk about is is relating to channel acceptance. Is if your peers, what happens if you're a node and you have a lot of peers connected to you, but these peers have marked you as disabled? So let's say you saw a node in the network, and 99% of their peers have marked them as disabled. And then you took another look at another node in the network, and only like 1% of the nodes has marked that node as disabled. I don't know if you know what marking as disabled means. It means that the forwarding policy is turned off. So it advertises through the gossip network to tell everybody, don't even try to forward to this person. I won't do it. So let's say you have a node and like it's all of its peers have marked it as disabled. What are you going to think about that node? Currently, we haven't coded anything to make conclusions based on that. But what you might want to think is, oh, well, that node, that's probably an offline node because everybody's marked it as disabled. Or at least there's a good chance that it is. So maybe I'll try the other node first. I don't mean to like go too into detail because I'm just talking about like a wide principle, which is that your nodes kind of reflect back on you. Who you've selected as your peers kind of give an idea of who you are. And so that's something that also could play into the channel acceptance policy is who do you want to like represent as being your peers? Okay, so another thing to think about when you're deploying your node is how should I advertise my node? So there's 3 different options that you have with your node. You can go for Tor, and L&D promotes the idea of doing Tor only, not having a clear IP plus a Tor IP, and that's a pretty cool solution if you're like changing your IP around just for selfish reasons. Now it's just more. It's just easier to like find you again because you have the same Tor like hidden address. And another nice thing about Tor is like it's not as straightforward to like attack you. Like, oh, you put this IP address, so like I'm gonna like spam your IP with a bunch of botnets or whatever. And I also think Tor is a nice selection for people who are routing because one thing about privacy on the chain versus off chain is on the chain you broadcast a transaction and it can come from any point, right? It can come from any point in the network. So if you broadcast it over Tor as well, and let's say we get Dandelion and stuff, it makes it kind of hard to like figure out who's the originator of that transaction. So if an exchange has to like identify who created that transaction, they're going to be like, oh, I don't know, I just saw it on the network, or I saw it as part of the blockchain. But what happens if an exchange receives a Lightning transaction? Well, they can actually say, I got it from this peer. And if you wanted to, you could go and if this peer has a clear IP, you could go and subpoena them and say, what's that IP? And then maybe you're saying like, oh, well, it was routed, it's onion routed, so they don't even know who they got it from. But if the person that they got it from has also a clear IP, you can just go and subpoena whoever they got it from. And if there's not a lot of hops, you can actually find who was the originator of the send. So Tor maybe helps with this. You can't really subpoena as easily the Tor provider because you have to go and get that exit hops. So I do like Tor as far as a routing node. And one of the bigger problems with it is that it's slower, right? We're like wrapping an onion inside of another onion. So we're getting a latency hit. And I think that's one thing we have to be careful of in our pathfinding algorithms is to try to not be too focused on absolute speed because there is this privacy component that you have a trade-off with. So a clear IP is nice in certain ways because it's easy. One great thing about it is like if we're depending on this data loss protection protocol and we want to be connecting to our peers when we've lost all of our data, well, how do we connect to our peers? If we're on a mobile phone like iOS and maybe we're not supporting Tor, so we want to connect to clear text IP addresses so that we can get our data back if we have a problem. So the way that I would deploy this is I would probably proxy it. So I would just make a kind of a proxy server that's not actually the real node, and I would put up another IP that you can kind of move around. And it's not so bad to change your IP address on the Lightning Network. I just did it actually. I moved my entire instance to another instance, changed the IP address, and because of the gossip system that updates your information about your node, I saw no issues at all. So a clear IP is actually pretty reasonable if you want it. Another option is to not have an IP. So when you're setting up your node, it might be a good idea just to have no way to connect to you. Like if somebody wants to attack your node and they don't have any way to address you at all, that's pretty secure. So that's another good option, especially if you're already kind of like well situated in the network. You've got a bunch of channels coming in, got a bunch of channels coming out. You can maybe for certain times and everything's very stable, you can maybe get rid of your IP advertisement. Okay, so some other like super basic things about deploying your node. If you're a routing node, you should kind of think about this as if it's kind of like a server. It's serving customers and they're paying for your business. So ideally, you should try to make it like have good uptime and stuff like that. And the way that you can kind of achieve that is make sure that your file descriptors are set up in a way that's like consistent with the server. Make sure that you have like flooding protection, just basic networking problems. That's something that we had seen in the start of the Lightning Network, is that people were just flooding using at the networking stack. They were just flooding servers. Another thing to think about is to just like lock down your ports. Don't allow things that you don't need to allow. And another thing I would definitely think about that maybe is not as common is to make sure that you're not getting eclipsed. So make sure that maybe if on your Bitcoin node, you add another peer that's somebody you know. And even your Lightning node could potentially get eclipsed. People could give you like weird nodes if they completely surround you. So it's nice to just make sure that you have that one. You just need one connection out to that greater gossip network. Okay, so something that I'm going to talk about that's a little bit farther out is this idea that we have of how to deploy like a production instance. Like let's say I'm an exchange or I'm an application developer, and I have like an app that interfaces a lot with Lightning, and I want to do it like in a logically secure way. So you can see here that I have this thing called the gateway node. So at the top, I have my service, I have a gateway, and then I have the world. I should have drawn a line between these. So the basic idea is if you have a service, you should launch 2 Lightning nodes. One Lightning node is a bare bones normal Lightning node. It doesn't have any application logic on it. And what you've created it for is for the idea of just running kind of like a regular routing node. And this one you connect to public people. You will maybe allow people to connect to you, or you connect out to some nodes. But you do not connect it to your actual application logic. Your application logic, you connect to your service node. So your service node, it never talks to anybody except for the gateway node. And the way that the gateway node and the service node are linked up is that there's a private channel. So you set up a private channel between them to say, if I want to send out, I always use that private channel. And if I want to receive in, then I use hop hints. And the big advantage to this is that you can totally lock down that server. And you can also kind of constrain the capital more easily. You can say like, even if that application just goes haywire and wants to spend $1 million, I only put $1,000 on that LND or on that node. So there's a limit. There's a logical limit to what it can possibly do. So that's kind of like just the basic advantage of having this 2-node setup. But in the future, we're envisioning this other advantage to the setup, which is this idea of policy limits that are enforced by a gateway node. So let's say that your application wanted to send $1 million, but you're an exchange, so sending $1 million isn't actually totally an unreasonable thing for you to do. So you actually did put $1 million on your service. Well, maybe you don't want to be sending out $1 million like all the time, though. Maybe you want like a second opinion if the service tries to send out that $1 million. So what you can do is you can say this gateway node doesn't have application logic on it, but what it does have is policy logic. And the policy logic could say, well, if I'm going to stop routing if something contravenes policy, I'm going to hold up the routing. So if you try to send out $1 million, I'm going to require like a hardware wallet to sign off a signature that says this is authorized, and only until I get that signature, I'm going to sit on this HTLC. I'm not going to let it go out to the rest of the network. So even though we don't have tools to do that, we don't have great tools to do that today. In the future, I can kind of see this becoming more of like the way to deploy things is to have your policy node and to have your application node. And another advantage of this is that a lot of people in the network today are kind of like, they have it in their minds that they want to connect to these named people. I want to connect to Bitrefill directly. I want to connect to all of these people who are operating like these big nodes and the people that they're transacting with directly. But it's it's difficult to make software that can just endlessly add peers, right? In Bitcoin, we have like 8 peers, and maybe we extend to like 100 peers, but we're not extending to hundreds of thousands of peers. So another advantage of the gateway node system is if you start to get a lot of peers on one node, you add in another gateway and another gateway. Or maybe you just want those multiple nodes for redundancy. So the way that you can do it is you just link up your however many service nodes you need to however many gateway nodes you need, and then you just add more or remove more as you need them. Okay, another LND specific kind of concept is this idea of macaroons, although you could implement it on anything, probably with hooks or whatever. So the big advantage of macaroons is basically just let's not have access to the node mean that you can do anything you want in the world. Let's have kind of limited access. We don't actually really implement this to a full extent in LND. We kind of just have like a stub of how it could work. But we have some kind of tokens that you can use today, and you can kind of see how it will be built out. And there's PRs that are there's some good contributions that are making it work more like how it should work, which is that what you should do is you should make the access token exactly fit what you want the person who has access token to do. So if you have an application, you should carefully define what the application can do. So if the application isn't supposed to send payments, it should not have an access token that can send payments. Or if it can only send payments, there's no reason that it needs the ability to create invoices. This can allow for cool applications, like maybe you have like your browser extension and you've given it like an allowance. You say, here you go, you can spend $5 a day, and that kind of limits the worst case scenarios that can happen. The first thing to think about is like scoping. That's what we have in these macaroons, is kind of like scoped access. Another thing to think about is like even how do you create the macaroon? How do you create this access token? So, and this is another area where LND currently doesn't do as good a job as it could, which is, let's say an attacker gets access to your machine and they want to steal all your money. At the moment, they can go in your LND directory and they can get the admin macaroon and they can say, send all the money to me. But we don't need to have the admin macaroon live in that LND directory. Instead, we can say that admin macaroon only lives somewhere else. It only lives like on the authorized computer that is admin. And the actual server instance, it doesn't even have that macaroon. And if we did get rid of it, the macaroon is kind of like a signature. It's like a signed attestation that you're allowed to do something. So it doesn't actually need to, the actual credentials don't need to live on the machine. So the hacker gets access to the machine, and they don't have that access control anymore. So they try to talk to the process, but since they don't have that file, they're not able to tell the process to go send money to their address. And we can even do better than that. We can actually like remotely initiate these tokens. So we don't even have to delete the tokens off the machine. We can make it so that the tokens are only created remotely, and they never even existed on the machine. So that's something that we hope to bring in the future to LND, is this idea of these remote access tokens that are limited in scope. The other thing to think about, just generally in terms of just going back to that policy question, is actually Bitcoin J, like back in the day, had all sorts of interesting ideas. And one of the ideas that they had is this idea of married wallets. So the idea was you would have a wallet maybe with your spouse, and then whenever because people used to get hacked a lot more frequently in Bitcoin for all sorts of reasons, and people were like kind of shaking their hands, like, how are we going to solve this hacking problem? And so people thought, oh well, let's have this multisig, and multisig will solve hacking. So people came up with this proposal, and it's in Bitcoin J, called married wallets. And the idea is that you stick your funds in a 2 of 2, and then if you need to send funds out, then you need a corresponding signature. So some wallets already exist like that. There's Green Wallet. But if you think about it, actually all Lightning wallets work this way, right? Every channel that we have is actually a 2 of 2. So we already all have married wallets. So all we need to do is just have policy that says, if I try to do something crazy, stop me from doing it. And we even have a feature already in the spec, which isn't really implemented in the implementations, but we have this idea of a closeout address. So the way that you could set up your channels is you could say that if a hacker got access to my machine, we've pre-negotiated that the only way that they can close out their channels is to go to my cold wallet address. It's not to go to hacker address it wherever. So don't allow that to happen. Don't allow me to change it. So the hacker then needs to not only hack you, but have to go to your peers and say, oh, I've hacked them, so that they will cooperate to sign this new commitment transaction. And we haven't used that too much yet, but we could even expand that to be much broader, to say that these policies that we thought about for the gateway nodes, they could actually be enforced by all sorts of nodes, on a more limited scale. Oh, that's it. Yeah.